Yeah, the previous speakers have given me a great introduction and background for what I'm going to talk about, because I'm going to focus in the latter part of my talk about changing estimates of frequency of extreme rainfall and how Harvey in particular has affected that, and what its consequences are going to be for floodplain identification, floodplain management in the Houston area. I'm also going to talk about longer-term factors, how things like natural variability and climate change affected storms like Harvey or have affected them. I'm going to start off by giving you some perspective on Harvey's unusual nature. We've already seen how unusual it is for Houston. I'm going to talk about how unusual it is basically anywhere in the United States. One thing I want to take exception to from the previous talks was a couple comments that Harvey was really a rain event for Houston rather than a hurricane. Well, if you look at the wettest rainfall events across the southern United States, the wettest storm ever in Alabama was a hurricane. The wettest storm ever in Georgia was a hurricane. The wettest storm ever in Florida was a hurricane. So unfortunately, our worst storms in this part of the world occur while a hurricane is happening also. We have to deal with both of them simultaneously, which really makes response difficult, really makes messaging to the public difficult, but unfortunately it's a challenge that we have to deal with. So, to start off with some statistics. The wettest storms ever in United States history, anywhere in the United States, over a 5-day duration, over an area of 10,000 square miles, because it's not just a point that causes flooding, it's rainfall over a big area. And the previous record is actually a storm that occurred back in 1899 in southeast Texas. The heaviest rainfall was in Hearn, just a few miles upstream of Texas A&M, where I'm from, produced a tremendous flood along the Brazos River. Didn't have a lot of gauges, but our best estimate is it was pretty big, and if you don't believe that number, Hurricane Beulah back in 1967, which was one of the strongest hurricanes ever to make landfall in Texas, was definitely a well-documented event. And if you're going to break those records, you'd expect maybe to see a storm of 22 inches or 23 inches, something like that. No, here's Harvey. This is an estimate based upon the River Forecast Center's flood analyses at the time of the event. I'm actually leading up a project where we've gathered data from all sorts of different sources, even members of the public entering their data on the website. I've got the best consulting firms that specialize in extreme rainfall analysis producing analyses, so we'll actually get reliable numbers after the fact of exactly how heavy that rain is. Not just for the point of statistics, but also for being able to drive hydrologic models, hydraulic models with the most accurate inputs possible so we can actually properly assess risk within Harris County and elsewhere in southeast Texas. This is a map of the rainfall from Harvey across southeast Texas. Certainly affected a big area, but I found a lot of people have trouble recognizing how big an area that is. It's just, one corner of the state of Texas. But if you superimpose the same rainfall map on the northeast United States, the area of 20 inches covers just about all of Massachusetts, all of Rhode Island, all of Connecticut, all of New York City, all the way upstream to Albany, and you throw in 20 inches in Philadelphia for good measure. So it's really, such a storm couldn't actually happen there meteorologically, but it shows you the sorts of rainfall conditions we have to deal with down here under exceptional circumstances. Now, the previous exceptional storm, you've heard about the 1935 flood in Houston, which motivated some of the major flood control measures that have been undertaken since then, such as Addison Barker Reservoir. There's not a whole lot of data available. I want to quote to you an excerpt from an official report that came out after the fact. The outstanding flood of December 1935 was the record-breaking overflow of Buffalo and White Oak bayous in Houston, Texas on the 8th and 9th. This destructive flood was caused by excessive rainfall over Harris County during a 42-hour period on the 6th through 8th. The greatest 24-hour rainfall in Houston was 5.38 inches on the 7th and 8th. But the catch in a standard rain gauge exposed at Satsuma, pumping station of the Humboldt Oil Company in the northwestern part of Harris County, was 16.49 inches, and catches of 21 inches were reported, but these were measured in improvised gauges and cannot be accepted as entirely reliable. So definitely 16.5 inches, maybe as much as 21 inches. That strange arrow on the slide is pointing to the location of Satsuma, which is along Highway 290 on a map of Harris County. So here's my map of Harris County, and these are showing the 42-hour rainfall totals ending Monday afternoon during Harvey, and you don't have to look very far to find 21-inch amounts. In fact, let's see. Yeah, I don't think there's a single gauge in Harris County at this time that wasn't knocked out by flooding that was showing less than 16.49 inches in a 42-hour period. So not only did this flood exceed the 1935 flood where it was measured, it exceeded the maximum total, the minimum total in Harris County exceeded the maximum from that flood. Okay, and let's get through this. This just basically shows that no matter what area size you choose, no matter what duration you choose, Harvey is basically the new record setter across the United States. With one exception, we'll have to reanalyze that one and see if we can make Harvey a clean sweep. Okay, everybody wants to know why a particular event happened, as long as a scientist can come up with an explanation of why it happened, people seem to be a lot more comfortable. They hate things happening randomly for no particular reason. There are lots of factors that contribute to a particular event, but weather is chaotic and weather happens. One thing that strongly affects our weather here, particular rainfall, is El Niño. People pay a lot of attention to El Niño and La Niña. This is a map of the correlation between the strength of El Niño and the amount of rainfall across the United States. And the reds are positive correlations. In southeast Texas, it's greater than a 0.5 value, where 1 would be perfect correlation. So a strong influence, except it's a strong influence when our weather is affected by the jet stream, which is mainly from October through the following April. So that's why I'm showing here. If we look at the summer months, like when Harvey happened, correlation is down around 0.1. So it's not, the El Niño doesn't really affect our summertime weather directly. It can reduce the chances of hurricane formation, and that's actually one of the reasons we're kind of optimistic about this year's hurricane season, because an El Niño is forming, so we probably won't have a massive number of hurricanes this year. Of course, it only takes one in the wrong place to cause great damage. A more important natural factor in the Atlantic Ocean is something called the AMO. It stands for Atlantic Multi-Decadal Oscillation. Sorry for having to say those words. And it tends to produce less rainfall over the central United States, indicated by the blue colors, when the Atlantic Ocean is running unusually warm. Now you would think that the Atlantic Ocean is warm, that should mean more thunderstorms and more rain. Well, it does to an extent. It means more thunderstorms and more rain happening over the Atlantic Ocean. And meanwhile, the land doesn't have unusually high temperatures, so you actually get less rain there. And so that's why the coastal areas here actually tend to see greater amounts of rainfall when the AMO is positive, when the Atlantic is unusually warm. But again, it's a fairly weak factor. So rainfall in Texas in the summertime is pretty much random, and that's why the seasonal outlook for this summer, as well as just about any other summer you look at, that comes out from the Climate Prediction Center, is predicting equal chances of above normal rainfall or below normal rainfall. And it's hard to argue with that forecast, really. Now, if we look at extreme rainfall on a county-by-county basis, we can look at trends. And in Houston, actually, there's a lot of talk about how there's been a lot of heavy rainfall. There's a lot of floods recently. If you look at the distribution of those trends, changes in rainfall only happens about once every decade or more, or less rather. You get lots of differences from place to place. The trend since 1950 in Galveston County is actually negative. There's a lot of noise here. There's not consistency from one place to another because we're talking about very rare events. And you could have two events happening in one county just as easily as you get one event here and one event there. And it makes a big difference for the overall trends. Overall on this map you see more blues than reds, which means the trends are generally positive. We've seen historically an increase in the frequency of extreme rainfall. But your local experience may vary, and indeed in Harris County, the trend has been more positive than most other places in the state. Harris County is this dark blue dot right there. Now maybe there's some physical reason for that to be going on. There are lots of possibilities people have suggested. For example, we know that Houston's air pollution actually has an influence on the way clouds and lightning and rainfall behave, but it certainly wasn't a factor in Harvey, where most of the precipitation was happening somewhere quite distant from where any pollution was happening, and indeed a lot of the refineries were shut down during Harvey anyway. So the pattern doesn't really match for that. Of course, there's been a lot of urbanization in Houston, so maybe that's affecting the ability of storms to develop and produce rainfall. The heat island could affect things. And that could be a factor, but if you look at other major metropolitan areas in the state of Texas, you don't find the same sort of localization. And the other counties that have big trends are rural counties. So that doesn't seem to be the explanation. Maybe there's a special configuration of Galveston Bay and the Gulf of Mexico influencing storm patterns, or maybe it's just being right along the coast where the trend is high. Well, again, there's nothing exceptional that seems to be happening along the coast. So this is one of those cases, I think, where you'd like there to be an explanation, but it's just basically the run of the dice that has unfortunately led to a lot of rain being focused on Harris County. Now, there have been a few studies already that have looked at how unusual the rainfall was in Houston during this event, or in southeast Texas. The one that I find most credible is this one, which looked at a bunch of stations all along the Gulf Coast. And the reason that's important is because Harvey probably could have happened anywhere within that box. I've looked at how frequently particular storms stall in particular areas, and there's nothing exceptional about us in that regard. And I already mentioned you get stalling storms with ridiculous rainfall totals elsewhere in the southeast too. So when you're looking at a really extreme event, you want to look at data over a large area, so you got a large pool of statistics to deal with. And you've actually seen graphs like this already this morning, where we look at the return period probability from left to right and rainfall amounts. going up to down or down to up. Professor Matthewson mentioned that the 500-year rainfall event for 3-day total was somewhere around 24 inches. That's basically what you get here. Look at 500 years and go up to these curves, and that's about the 24-inch mark. So that's how you read this thing. You can pick a frequency and find the amount it corresponds to. Or you can look at it the other way. If you give an amount, how often do you expect that sort of event to recur? What's the likelihood of it occurring in any given year? We've got two curves here because this particular study included allowing for the possibility that the frequency was correlated with global average temperatures. And they found a correlation within that region, and the red basically is the probability corresponding to 2017 conditions. The blue is the probability corresponding conditions back in 1900 at the beginning of the period. What you see is the envelope of red curves, the upper bound, the best estimate, the lower bound, are generally higher than the envelope of the blue curves, which means that the probability of a given amount has increased. In the case of Harvey, which wasn't even included in these statistics to not bias the analysis, but the greatest 3-day rainfall total at any of the regular climate stations was at Liberty, Texas. They got 41 inches, that's that green line up there. And I had to extend those lines by hand to actually be able to see where that comes out back in the year 1900. But the odds of such an event happening at any given location in that region, pick your location, the odds are 1 in 9,000 by this estimate, give or take a few thousand. Whereas back in 1900, the odds were 1 in 27,000 in any given year. And those numbers don't really mean as much as the fact that the newer number is a third the size of the older number, which means the odds of an event of this magnitude have gone up by a factor of 3 according to this analysis. So we've got that difference in return frequency. Or you can look at it in terms of rainfall amounts. If you want to figure out how much such a rare event has changed in terms of amount, you look vertically. And what corresponds to 41 inches today, 1 in 9,000 year event, would have been a 34-inch event back in 1900. So the amount associated with a given risk has increased by about 15% or so over the course of the century plus, assuming that that risk is, as the statistics say, correlated with global temperature. Now that analysis is independent of what's causing the trend in global temperatures, which is mainly anthropogenic, but they compared it to model simulations that are driven by changes in atmospheric composition and all of that, and got similar numbers. So you get the same answer no matter how you look at it, basically. Now, Harvey is somewhat academic in this regard, but it has practical importance when we get down to what's called NOAA Atlas 14. A ridiculous name for something, but it's an important thing to keep in mind because that's the standard by which something like a 100-year rainfall amount is estimated, which then gets used to estimate the 100-year flood, which determines where the floodplain is, and so on and so on. So those numbers are important. The latest official one from NOAA was back in 1961. Professor Matthewson showed you some analysis was done by the USGS about 20 years ago. The new one is in progress. They've already gone through 2 rounds of external reviews, and the results from that are scheduled to come out in October, and the documentation in December. So when that happens, across all of Texas, the estimated value of the 100-year rainfall event will change. Consequently, the extent of the 100-year floodplain will change once the hydrologists do the calculations and all of that. And there are a lot of reasons for that change to happen. So, for example, we've got better methods. We actually didn't really have computers in 1961. So we can do much more sophisticated statistical analyses. There's a lot more stations that have been available over that time period. Each one has a longer data record than it would have had back in 1961. But also, as I showed, rainfall is intensifying. And that, I think, is the primary reason that in all of the drafts that have come out so far, the average rainfall across, 100-year rainfall across Texas in this analysis is higher than the average 100-year rainfall back in the previous version. And in fact, even the current version assumes that all the historical statistics are valid. It's not assuming that the climate's changing, it's just taking the data that's occurred up through 2017. Which in a sense means that the future analysis is out of date in the sense that it's not taking into account what the actual current risk is. It's more an assessment of what the historic risk is. So now, let's put those two main factors I talked about together. I said Harvey was extremely unusual, perhaps a 1 in 10,000 year event or thereabouts. And NOAA Atlas 14 is analyzing historical data, assuming that historical statistics apply to the future. Those are actually two competing effects, because since Southeast Texas was lucky enough to experience Harvey, we have a very extreme rainfall event that influences the assessment of risk for all sorts of risk levels. And as a result of that, again in the preliminary draft, because of Harvey alone, the estimates of the multi-day 100-year rainfall amounts are higher by about 10% than they would have been otherwise. But the overall increase in Houston compared to the 1961 analysis is going to be even greater than that, because there have been other floods since then. Plus, there's this underlying long-term trend. So, in one sense, NOAA Atlas 14 sort of underestimates things because the odds of extreme rainfall have increased in general and are expected to increase because of climate change. So we're looking at the historic risk rather than what we should be building for, which is the future risk. But then on the other hand, I know we've been warned about people who say on the other hand, but I got to do it here. On the other hand, the risk in Houston has become sort of artificially greater because we've been unlucky. And so I think the risk is being slightly overestimated because of having had Harvey and a couple other floods here that haven't happened in Victoria for no particular physical reason. So, in a sense, those two effects sort of help work each other out, because although I personally think the new NOAA Atlas 14 is going to be overestimating the actual historical risk, it's not overestimating the actual future risk, because climate change is going to catch up with the unlucky nature of what's happened in Houston, because sooner or later, everybody's going to be that unlucky. Okay, I'll leave it at that. I'll be happy to answer questions.
Do we have any questions for the audience? From the audience, rather.
Either way, I can ask questions if they don't want to.
Go ahead, ask me.